A lake is an area of variable size filled with water, localized in a basin, that is surrounded by land. Apart from any river or other outlet that serves to feed or drain the lake, lakes lie on land and are not part of the ocean, and therefore are distinct from lagoons, and are also larger and deeper than ponds. Though there are no official or scientific definitions, lakes can be contrasted with rivers or streams, which are usually flowing. However, most lakes are fed and drained by rivers and streams. Natural lakes are generally found in mountainous areas, rift zones, and areas with ongoing glaciation. Other lakes are found in endorheic basins or along the courses of mature rivers. In some parts of the world there are many lakes because of chaotic drainage patterns left over from the last ice age. All lakes are temporary over geologic timescales, as they will slowly fill in with sediments or spill out of the basin containing them. Many lakes are artificial and are constructed for industrial or agricultural use, for hydroelectric power generation or domestic water supply, or for aesthetic or recreational purposes. Etymology, meaning, and usage of lake. The word lake comes from Middle English lake, from Old English lacu, from Proto-Germanic *lekor, from the Proto-Indo-European root *leg. Cognates include Dutch lak, Middle Low German lake, German Leiche, and Icelandic lakur, also related to the English words leek and leech. There is considerable uncertainty about defining the difference between lakes and ponds, and no current internationally accepted definition of either term across scientific disciplines or political boundaries exists. For example, limnologists have defined lakes as water bodies which are simply a larger version of a pond, which can have wave action on the shoreline or where wind-induced turbulence plays a major role in mixing the water column. None of these definitions completely excludes ponds, and all are difficult to measure. For this reason, simple size-based definitions are increasingly used to separate ponds and lakes. One definition of lake is a body of water of 2 hectares or more in area. However, others have defined lakes as water bodies of 5 hectares and above, or 8 hectares and above. Charles Elton, one of the founders of ecology, regarded lakes as water bodies of 40 hectares or more. The term lake is also used to describe a feature such as Lake Eyre, which is a dry basin most of the time but may become filled under seasonal conditions of heavy rainfall. In common usage, many lakes bear names ending with the word pond, and a lesser number of names ending with lake are in quasi-technical fact, ponds. One textbook illustrates this point with the following. In Newfoundland, for example, almost every lake is called a pond, whereas in Wisconsin, almost every pond is called a lake. One hydrology book proposes to define the term lake as a body of water with the following 5 characteristics. It partially or totally fills one or several basins connected by straits, has essentially the same water level in all parts. It does not have regular intrusion of seawater. A considerable portion of the sediment suspended in the water is captured by the basins. The area measured at the mean water level exceeds an arbitrarily chosen threshold, with the exception of the seawater intrusion criterion. The others have been accepted or elaborated upon by other hydrology publications. Distribution of lakes. The majority of lakes on Earth are freshwater, and most lie in the northern hemisphere at higher latitudes. Canada, with a deranged drainage system, has an estimated 31,752 lakes larger than 3 square kilometers and an unknown total number of lakes, but is estimated to be at least 2 million. Finland has 187,888 lakes 500 square meters or larger, of which 56,000 are large or larger. Most lakes have at least one natural outflow in the form of a river or stream, which maintain a lake's average level by allowing the drainage of excess water. Some lakes do not have a natural outflow and lose water solely by evaporation or underground seepage or both. They are termed endorheic lakes. Many lakes are artificial and are constructed for hydroelectric power generation, aesthetic purposes, recreational purposes, industrial use, agricultural use or domestic water supply. Evidence of extraterrestrial lakes exists. Definitive evidence of lakes filled with methane was announced by NASA as returned by the Cassini probe, observing the moon Titan, which orbits the planet Saturn. Globally, lakes are greatly outnumbered by ponds. Of an estimated 304 million standing water bodies worldwide, 91% are 1 hectare or less in area. Small lakes are also much more numerous than large lakes. In terms of area, 1/3 of the world's standing water is represented by lakes and ponds of 10 hectares or less. However, large lakes account for much of the area of standing water, with 122 large lakes of 1,000 square kilometers or more representing about 29% of the total global area of standing inland water. Origin of natural lakes. Since they progressively become filled by sediment, lakes are considered ephemeral over geological time scales, and long-living lakes imply that active processes keep forming the basins in which they form. There are a number of natural processes that can form lakes. Tectonic lakes. The longest living lakes on Earth are related to tectonic processes. A tectonic uplift of a mountain range can create depressions that accumulate water and form lakes. Landslide and ice dam lakes. Lakes can also form by means of landslides or by glacial blockages. An example of the latter occurred during the last ice age in the U.S. state of Washington, when a huge lake formed behind a glacial flow. When the ice retreated, the result was an immense flood that created the dry falls at Sun Lakes, Washington. Salt lakes. Salt lakes can form where there is no natural outlet or where the water evaporates rapidly and the drainage surface of the water table has a higher than normal salt content. Examples of salt lakes include Great Salt Lake, the Aral Sea and the Dead Sea. Oxbow lakes. Small, crescent-shaped lakes called oxbow lakes can form in river valleys as a result of meandering. The slow-moving river forms a sinuous shape as the outer side of bends are eroded away more rapidly than the inner side. Eventually a horseshoe bend is formed and the river cuts through the narrow neck. This new passage then forms the main passage for the river, and the ends of the bend become silted up, thus forming a bow-shaped lake. Crater lakes. Crater lakes are formed in volcanic craters and calderas which fill up with precipitation more rapidly than they empty via evaporation. Sometimes the latter are called caldera lakes, although often no distinction is made. An example is Crater Lake in Oregon, in the caldera of Mount Mazama. The caldera was created in a massive volcanic eruption that led to the subsidence of Mount Mazama around 4860 BC. Glacial lakes. The advance and retreat of glaciers can scrape depressions in the surface where water accumulates. Such lakes are common in Scandinavia, Patagonia, Siberia and Canada. The most notable examples are probably the Great Lakes of North America. As a particular case, flow lakes are basins that have emerged from the sea as a consequence of post-glacial rebound, and are now filled with fresh water. Other lakes, such as Lake Jackson in Florida, USA, come into existence as a result of sinkhole activity. Lake Vostok is a subglacial lake in Antarctica, possibly the largest in the world. The pressure from the ice atop it and its internal chemical composition mean that, if the lake were drilled into, a fissure could result that would spray somewhat like a geyser. Most lakes are geologically young and shrinking since the natural results of erosion will tend to wear away the sides and fill the basin. Exceptions are those such as Lake Baikal and Lake Tanganyika that lie along continental rift zones and are created by the crust's subsidence as two plates are pulled apart. These lakes are the oldest and deepest in the world. Lake Baikal, which is 25 to 30 million years old, is deepening at a faster rate than it is being filled by erosion and may be destined over millions of years to become attached to the global ocean. The Red Sea, for example, is thought to have originated as a Rift Valley lake. Types of lakes. Periglacial lake. Part of the lake's margin is formed by an ice sheet, ice cap or glacier, the ice having obstructed the natural drainage of the land. Subglacial lake. A lake which is permanently covered by ice. They can occur under glaciers, ice caps or ice sheets. There are many such lakes, but Lake Vostok in Antarctica is by far the largest. They are kept liquid because the overlying ice acts as a thermal insulator, retaining energy introduced to its underside by friction, by water percolating through crevasses, by the pressure from the mass of the ice sheet above, or by geothermal heating below. Glacial lake. A lake with origins in a melted glacier, such as a kettle lake. Artificial lake. A lake created by flooding land behind a dam called an impoundment or reservoir, by deliberate human excavation, or by the flooding of an excavation incident to a mineral extraction operation such as an open-pit mine or quarry. Some of the world's largest lakes are reservoirs like Hirakud Dam in India. Endorheic lake, terminal or closed. A lake which has no significant outflow, either through rivers or underground diffusion. Any water within an endorheic basin leaves the system only through evaporation or seepage. These lakes, such as Lake Eyre in central Australia or the Aral Sea in Central Asia, the Great Salt Lake in western United States, are most common in deserts. Maromatic lake. A lake which has layers of water which do not intermix. The deepest layer of water in such a lake does not contain any dissolved oxygen. The layers of sediment at the bottom of the maromatic lake remain relatively undisturbed because there are no living aerobic organisms. Fjord lake. A lake in a glacially eroded valley that has been eroded below sea level. Oxbow lake. A lake which is formed when a wide meander from a stream or a river is cut off to form a lake. They are called oxbow lakes due to the distinctive curved shape that results from this process. Rift lake or sag pond. A lake which forms as a result of subsidence along a geological fault in the Earth's tectonic plates. Examples include the Rift Valley lakes of eastern Africa and Lake Baikal in Siberia. Underground lake. A lake which is formed under the surface of the Earth's crust. Such a lake may be associated with caves, aquifers or springs. Crater lake. A lake which forms in a volcanic caldera or crater after the volcano has been inactive for some time. Water in this type of lake may be fresh or highly acidic, and may contain various dissolved minerals. Some also have geothermal activity, especially if the volcano is merely dormant rather than extinct. Lava lake. A pool of molten lava contained in a volcanic crater or other depression. Lava lakes that have partly or completely solidified are also referred to as lava lakes. Former. A lake which is no longer in existence. Such lakes include prehistoric lakes and lakes which have permanently dried up through evaporation or human intervention. Owens Lake in California, USA, is an example of a former lake. Former lakes are a common feature of the basin and range area of southwestern North America. Ephemeral lake, intermittent lake, or seasonal lake. A seasonal lake that exists as a body of water during only part of the year. Shrunken. Closely related to former lakes, a shrunken lake is one which has drastically decreased in size over geological time. Lake Agassiz, which once covered much of central North America, is a good example of a shrunken lake. Two notable remnants of this lake are Lake Winnipeg and Lake Winnipegosis. Eolic Lake. A lake which forms in a depression created by the activity of the winds. VLEI, in South Africa, shallow lakes which vary considerably with seasons. Epichelf lakes, unique lakes which exist on top of a dense saltwater body and are surrounded by ice. These are mostly found in the Antarctica. Characteristics. Lakes have numerous features in addition to lake type, such as drainage basin, inflow and outflow, nutrient content, dissolved oxygen, pollutants. pH, and sedimentation. Changes in the level of a lake are controlled by the difference between the input and output compared to the total volume of the lake. Significant input sources of precipitation onto the lake runoff carried by streams and channels from the lake's catchment area, groundwater channels and aquifers, and artificial sources from outside the catchment area. Output sources are evaporation from the lake surface and groundwater flows, and any extraction of lake water by humans. As climate conditions and human water requirements vary, these will create fluctuations in the lake level. Lakes can be also categorized on the basis of their richness in nutrients, which typically affect plant growth. Nutrient-poor lakes are said to be oligotrophic, and are generally clear, having a low concentration of plant life. Mesotrophic lakes have good clarity and an average level of nutrients. Eutrophic lakes are enriched with nutrients, resulting in good plant growth and possible algal blooms. Hypertrophic lakes are bodies of water that have been excessively enriched with nutrients. These lakes typically have poor clarity and are subject to devastating algal blooms. Lakes typically reach this condition due to human activities, such as heavy use of fertilizers in the lake catchment area. Such lakes are of little use to humans and have a poor ecosystem due to decreased dissolved oxygen. Due to the unusual relationship between water's temperature and its density, lakes form layers called thermoclines, layers of drastically varying temperature relative to depth. Fresh water is most dense at about 4 degrees Celsius at sea level. When the temperature of the water at the surface of a lake reaches the same temperature as deeper water, as it does during the cooler months in temperate climates, the water in the lake can mix, bringing oxygen-starved water up from the depths and bringing oxygen down to decomposing sediments. Deep temperate lakes can maintain a reservoir of cold water year-round, which allows some cities to tap that reservoir for deep lake water cooling. Since the surface water of deep tropical lakes never reaches the temperature of maximum density, there is no process that makes the water mix. The deeper layer becomes oxygen-starved and can become saturated with carbon dioxide, or other gases such as sulfur dioxide if there is even a trace of volcanic activity. Exceptional events, such as earthquakes or landslides, can cause mixing, which rapidly brings the deep layers up to the surface and release a vast cloud of gas which lay trapped in solution in the colder water at the bottom of the lake. This is called a limbic eruption. An example is the disaster at Lake Nyos in Cameroon. The amount of gas that can be dissolved in water is directly related to pressure. As deep water surfaces, the pressure drops and a vast amount of gas comes out of solution. Under these circumstances, carbon dioxide is hazardous because it is heavier than air and displaces it. So it may flow down a river valley to human settlements and cause mass asphyxiation. The material at the bottom of a lake, or lake bed, may be composed of a wide variety of inorganics, such as silt or sand, and organic material, such as decaying plant or animal matter. The composition of the lake bed has a significant impact on the flora and fauna found within the lake's environs by contributing to the amounts and the types of nutrients available. A paired layer of the varved lake sediments correspond to a year. During winter, when organisms die, carbon is deposited down, resulting to a black layer. At the same year, during summer, only few organic materials are deposited, resulting to a white layer at the lake bed. These are commonly used to track past paleontological events. Natural lakes provide a microcosm of living and non-living elements that are relatively independent of their surrounding environments. Therefore, lake organisms can often be studied in isolation from the lake's surroundings. Limnology. Limnology is the study of inland bodies of water and related ecosystems. Limnology divides lakes into 3 zones. The littoral zone, a sloped area close to land, the photic or open water zone, where sunlight is abundant, and the deep water profundal or benthic zone, where little sunlight can reach. The depth to which light can reach in lakes depends on turbidity, determined by the density and size of suspended particles. A particle is in suspension if its weight is less than the random turbidity forces acting upon it. These particles can be sedimentary or biological in origin and are responsible for the color of the water. Decaying plant matter, for instance, may be responsible for a yellow or brown color, while algae may cause greenish water. In very shallow water bodies, iron oxides make water reddish-brown. Biological particles include algae and detritus. Bottom-dwelling detritivorous fish can be responsible for turbid waters, because they stir the mud in search of food. Piscivorous fish contribute to turbidity by eating plant-eating fish, thus increasing the amount of algae. The light depth or transparency is measured by using a Secchi disc, a 20 cm disc with alternating white and black quadrants. The depth at which the disc is no longer visible is the Secchi depth, a measure of transparency. The Secchi disc is commonly used to test for eutrophication. For a detailed look at these processes, see lentic ecosystems. A lake moderates the surrounding region's temperature and climate because water has a very high specific heat capacity. In the daytime, a lake can cool the land beside it with local winds, resulting in a sea breeze. In the night, it can warm it with a land breeze.